So what other types of questions can we do for the geometric sequence? Another example could be this, right? The fourth term of a geometric sequence is 125, and the 10th term is 125 over 64. We want to find the 14th term, and we are going to assume all terms are positive, right? Unless it's stated, we don't want to necessarily assume that, especially though on this one we want to assume because notice that I gave you both even numbers, the 4th and the 10th term. So let's think about what we have. I said that the 4th term, a of 4, right, was equal to 125. What else I was given was that it was the 10th term, and the 10th term was 125 over 64. Right? Those are the two pieces of information. So what I want to do is I kind of want to set up a system to try to figure out what I know. So I'm going to go back to my formulas, and I can use any sets of these. I just got to figure out which one I want to use. Okay, so I'm going to say a of 4 is equal to, and I'm going to start with a of 1 times my ratio, since I don't know my ratio, and it will be n, which is 4, minus 1. I can rewrite this problem as a of 4 is equal to a of 1, and then r cubed. So now I know a of 4, so let's go ahead and erase this, a of 4, and actually write what a of 4 is equal to. One less variable to work with. So really what I need to do is I need to figure out what my r value is. So I'm going to do the same thing one more time. I'm going to say a of 10 is equal to a of 1 to times r to the power of 10 minus 1. So I now know what a of 10 is. It's 125 over 64. And then a of 1. And then r to the power of 9. So what I think I'm going to do is I'm going to simplify this equation. I'm going to divide both sides by r cubed. So I'm going to get 125 over r cubed is equal to a of 1. I'm going to take that guy, plug it in over here. So what does this look like? It looks like 125 over 64 is equal to 125 r cubed times r9. I'm going to run out of space, so let me just put that information onto a new page. So we said it's 125 over 64 is equal to 125 r cubed times r to the power of 9. Let me make sure I wrote that correctly. I did. So let's simplify this. It's 125 over 64 is equal to 125 r to the power of 6. So using my exponent rules, right, r9 over r3 is really r9 minus 3, which gives us r to the power 6. Over here, instead of dividing, because then I'm going to have a giant fraction, I'm going to multiply this side by 1 over 125. I'm going to do the same thing over here. 1 over 125, and I'm going to notice everything cancels each other out. 1 over 64 is equal to r to the power of 6. Now, at this point, we could do one of two things. We could either take our trusty calculator, which is turned off, so we'll have to turn it back on, and we are going to take the 6th root. So in order to do that, notice that Option number 5, if I press math in option 5, it says x and then a root sign. So I want to write a number there first. So let me quit out of this, so second mode, and I'm going to put 6 right there. Go back to math, press 5, and now notice I'm about to take the 6th root, because on this page, right, I am going to have to take the 6th root in order to get rid of the 6th degree. So I'm going to plug in 1 over 64. Close parentheses, press enter, and I get 0.5. So on this side, r is equal to 0.5, which is the same thing as 1/2, either one. Now, without a calculator, what I would do is I would break down 64. So I know 64 is made up of 8 and 8. This is made up of 4 and 2 and 4 and 2. There's 2 and 2. There's 2 and 2. So technically, 1 over 64 is 1 over 2 to the power 6, which is the same thing as saying 1/2 to the power of 6, right? So if I know that 1/2 to the power of 6 is equal to r to the power of 6, they have the same exponent, r must equal 1/2. So that's essentially what you want to do. So going back to the original question, it's asking us to find the 14th term. Okay, so let's find the 14th term. So let's get a new page. So we're going to say a of 14. So what I am going to do is this. I'm going to say a of 10. And then I'm going to use my r, and then this will be your n minus 10. Again, I don't need my first value. I know what my 10th term is, right? 10th term was 125 over 64. Oops, not 124. And my r value was 1/2. And 14 minus 10. Oops, 64. So this will be 125 over 64 times 1/2 to the power of 4. So 1 to the power of 4 is just 4. 2 to the power of 4 is 16. So 125 over 64 times 1 over 16. Right? And in case we forgot, 64 times 16, quickly do the math, gives us 1024. So this means our 14th term is 125 over 1024. So those are all the different types of sequences that we can do. Obviously, I could just give you a sequence and ask you what are all the terms in it. Right? So the next thing that we are going to discuss is how do we actually find the sum of a sequence. There's two types of sums that we're going to find. First, going to talk about sum of a finite geometric sequence. Now, worst comes to worst, all you have to do is add them up, right? That's what sum means. So our r value again for this cannot equal 1. So there is a formula, and this is kind of what it looks like. So S is going to stand for sum, right? The summation of n. And we are going to use that summation symbol again, right? Sigma. And I'm going to start with a number. Who knows what that number is, right? But I'm just going to call it I is equal to 1, right? So the letter is equal to 1. And I'm going to go to my most terms. So this is saying my sequence is starting with the first term and ending with whatever term I have here. And then what you're going to see is you're going to see the equation, or the expression, I should say. A of 1 times r to the power of I minus 1. So that's summation. This will be the same thing as saying this. A of 1 times 1 minus r to the power of n all over 1 minus r. So all this is a giant substitution problem. That's all. So how do I actually use this? All right. So we're going to say this. Find the sum. And I'm going to say n is equal to 1 and 12. So I just want to recall, remember this is what's known as a lower limit. That's where our sequence is going to start. Up here is our upper limit. Okay. And here is our expression. So we're going to say 4 times 0.3 to the power of n. So if I'm looking at this problem, I know that this is actually not my first term. That is my 0th term because I don't see a minus 1. I know that this is my ratio. So in order to use my formula, a of 1 times 1 minus r to the power of n all over 1 minus r, I need a few things. I need to know what my first term is. I need to know what my ratio is. And I need to know how many terms there are. So let's start with the ratio. Boom. That's easy. R is equal to 0.3. N. How do we find the n? Well, n is equal to, so this starts at 1, goes to 12. So if I think about it, right, I'm doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, went too far. Notice I have 12 terms. So that means n is equal to 12. So the only thing left to find is a of 1. So let's go ahead and plug in 1 into this equation. So a of 1 is equal to 4 times 0.3 to the power of 1. So in reality, all we're doing is we're multiplying 4 times 0.3, which is going to leave us with 1.2. So we're going to use all this information. So the sum of 12 numbers is 1.2 times 1 minus 0.3 to the power of 12 all over 1 minus 0.3. My suggestion, I'm not going to ask you to raise 0.3 to a power of 12 without a calculator. I don't need you to do that. So 1.2 parentheses. Now this whole thing's going to be in parentheses, so I'm actually going to use double parentheses. I'm going to say 1 minus 0.3 to the power of 12. There's my, oops, delete. Let's get out of the exponent. So here's my numerator divided by denominator. So 1 minus 0.3, close, and I need to close one more time. Press enter, and we get about 1.714284803. Again, let's just round to 1 or 2 decimal places. So 1.714 is perfectly fine. So the sum of 12 terms is 1.714. Again, I could have found all 12 terms and added them up, but isn't a formula so much easier? Why don't you go ahead and try this one next. What is the sum of this? 2 to the power of n minus 1, starting at 1, going to 7.